why energy-efficient buildings must lead the next phase of sustainability, plus 5 practical strategies to cut building energy use and strengthen grid resilience. This industry voice is from Kelsey Herring, the Director of Sustainability and Government Relations at Armstrong World Industries. As energy demand climbs worldwide, the path to sustainability is no longer just about adding renewable power to the grid. It's about using energy far more intelligently. Even as renewable capacity grows, transmission bottlenecks, weather volatility, and the rapid electrification of vehicles, heating, and industry are straining supply. The International Energy Agency reports that buildings account for roughly 30% of global final energy consumption and 26% of energy-related emissions. That makes the built environment one of the most powerful and underutilized levers for reducing energy demand and emissions. From the grid to the building envelope, heating, cooling, and lighting drive the majority of building energy use. Every design choice, from insulation and glazing to airflow management and ceiling assemblies, influences how efficiently those systems operate. Yet, efficiency is too often treated as an incremental upgrade rather than a strategic imperative. A recent industry discussion involving my company and the International Facility Management Association, IFMA, Jones Lang LaSalle, JLL, CBRE Group, and other partners reinforced that demand-side efficiency must now lead the next wave of climate and cost innovation. The opportunity is to design spaces that passively conserve energy while supporting comfort, productivity, and health, a combination that benefits both businesses and the planet. 5 practical solutions for reducing building energy use. 1. High-performance envelopes and interiors. Thermally efficient wall and ceiling systems can reduce unwanted heat transfer between conditioned and unconditioned areas, easing HVAC loads and stabilizing indoor temperatures. Materials with built-in insulation or air barrier properties lower heating and cooling demand without sacrificing design flexibility. 2. Integrated system design. When building elements work together, HVAC, ceilings, lighting, and controls, efficiency improves exponentially. Integrated design enables more consistent temperature regulation and airflow with less mechanical effort, translating to measurable reductions in operational energy use. 3. Smart monitoring and controls. Digital building management platforms now allow real-time tracking of occupancy, temperature, and humidity. When paired with efficient materials and design, these systems fine-tune energy use dynamically and identify inefficiencies before they escalate. 4. Renovation strategies for existing buildings. Most buildings that will stand in 2050 already exist. Renovating thermal barriers, sealing plenums, and installing modular ceiling or wall systems that enhance thermal performance can deliver quick, low-disruption gains in efficiency and comfort. 5. Life cycle and embodied carbon performance. Operational savings are magnified when materials last longer. Durable, modular systems that extend replacement cycles and can be recycled at end of life reduce both cost and embodied carbon, supporting circular economy goals. Together, these interventions form a holistic framework for demand-side energy management, maximizing every kilowatt while strengthening grid resilience. Why this matters beyond the building sector. Energy efficiency in buildings isn't just the concern of architects and facility managers. Companies across industries are under pressure to decarbonize their operations and disclose climate progress. Yet many overlook the fact that workplaces, retail locations, warehouses, and data centers are often their largest sources of indirect, Scope 2 emissions. By incorporating efficiency criteria into procurement, leasing, and renovation decisions, businesses can meaningfully advance their sustainability targets. Corporate tenants can prioritize energy-efficient spaces and track performance data through green leasing frameworks. Manufacturers and logistics providers can renovate facilities to cut energy intensity per unit produced or shipped. Tech companies expanding data infrastructure can offset part of their growing demand through smarter building envelopes and cooling systems. These choices not only reduce emissions, but also build resilience against energy price volatility, a growing financial risk for all sectors. Economics, policy, and collaboration. The economics are compelling. Every watt saved through design innovation translates into lower operating costs and stronger asset value. Updated standards such as LEED v5, ASHRAE 90.1, and emerging building performance standards are making efficiency a regulatory and financial imperative. Incentives, from efficiency credits to local renovation retrofit grants, are helping close the gap between ambition and adoption. Progress will depend on collaboration. Designers, material scientists, policymakers, and corporate sustainability teams each hold part of the solution. Aligning product innovation, building codes, and investment priorities can turn efficiency from a compliance exercise into a competitive advantage. From challenge to opportunity, reducing energy demand in buildings is one of the fastest, most cost-effective ways to advance climate and economic resilience simultaneously. Every insulated panel, airtight seal, smart sensor, or integrated design represents a step toward a future where buildings help stabilize, rather than strain, the grid. The cleanest and cheapest energy will always be the energy we don't use. Embedding that principle across the built environment and in corporate sustainability strategies alike is how we turn climate goals into measurable progress.